question 79, word search from LeetCode. Let's jump to the question. Given an n by n grid of character board and a string word, return true if word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring, and the same letter cell may not be used more than once. So let's see what this question is talking about. And the question is saying like n by n board is given to us, and we are going to look for a word, and if we can find it, return true, and if not, we are going to return false. And the thing that is saying here, we are going to check the adjacent cells, and adjacent cells are horizontally adjacent or vertically adjacent, and we may not use a letter in a cell more than once. So let's see this example. In this example, this word is given and we are looking for this word, and as you can see, this word exists here and we are going to return true. So let's see another example. In this example, this word is given and we are looking for word C, and as you see, we have this word here and we are going to return true. And in this word, we are going to look for A, B, C, B, which we cannot find it, and we are going to return false. Let's jump to the solution and see how we can solve this problem. So the way that we can solve this problem is like we can iterate over this board and find the letters. But the way we can do it is because it can be adjacent horizontally or vertically. So the way we can do it is we cannot go with just one for loop, we cannot find it. So we need to use backtracking a recursive function to check all the four corners for every single letter that we can find in the board. So how we can do that? We are going to use two for loops, one for I that we have here, and one for I that we have here, and one for J, which is the columns, and I are the rows, right? So we are going to iterate every single letter here until we find the first letter of the word that we are looking for. In this example, we have this word, and the word that we are looking for is C. The first letter is S, and at index 0, at index 1 we have E, at index 2 we have 2. So what we're going to do, we are going to call the DFS function and see if that letter that we are pointing at is the letter that we are looking for. So we start from here, we have letter A here, and this is the line that we check the condition and see if the letter that we are at, the index that we are at that point is the letter that we are looking for. And we have four more conditions here. We are saying if I is smaller than 0, or J is smaller than 0, or I is equal to the length of the board, or J is equal to length of the board, and all these conditions are referring to if we are outside of this word, if the indices that we are talking about are outside of this board, right? This board, so we are going to return false. And also if the cell that we are pointing at is not equal to the first letter of that word at index 0. If it is not, we are going to return false. So let's iterate over this board and to grasp the concept and this code better. So we are at this point, letter A at index 0, as you see, is not equal. This is the one that we are pointing at right now. So S is not equal to A, so we go to the we are going to through this for loop, and the I is going to be 0, J is going to be 1. So we are at this point, B is not equal to S, so I is equal to 0, J is equal to 2, C is not equal to S, E is not equal to S, and now at this point at index 1 and 0, S is equal to S. So what we are going to do, we are pass at this condition, right? So what we are going to do, we are going to put a hashtag for that I and j that we have, I1 and j0. We are going to put hashtag here, right? And what we are going to do, we are going to check all the four corners of this index, right? All the four corners of in this index to see if we can find the next letter, because we have already find S. Now we are looking for E. So the way we do that, we are going to add add one and minus one, the indices, and see if we can find it. The reason that we start from index 1 is because we have already found S, so we need to check the rest, right? So we start checking that. So we check 1 and 1, which is F here, so it's not equal to E, that's false. And then we check 0 and 0, it is A, and A is not equal to E, so this is going to be false too. We check 1 and minus 1, and because it's minus, so it's gonna be false too. And we are going to check 2 and 0, which is going to be A, and this is going to be false too. What will happen here if this for loop is not going to return anything? What is going to happen here? We are going to put that S back there, and we are going to remove hashtag from here, right? So this is what we're going to do. We are going to remove hashtag and we put it back there, and we keep iterating over the board. So now we check 1 and 1, F is not equal to S. Now we are back to S, right? So we are checking, we are looking for S again, right? So we are looking for S again. So this is not equal to S, this is not equal to S, and this is equal to S. And as I mentioned, if if this condition is not true, we are going to put a hashtag here, right? And we are going to check all the four corners. And while we are checking the corners, so as you see at index 1 and index 0, we have S. So we have S here, we are going to put hashtag, and then we check all the corners, and at index 0 and 3 we have E, which is this next item that we were looking for. So we are going to put hashtag here too, and then now we are going to eliminate E, and we are going to check all the four corners of this to see if we can find another E that we are looking for, the third in for the third item that we are looking for. And so what will happen here, we know this is S and this is outside, and this is what we have iterated already before. This is hashtag. This is the good thing about putting hashtag here. If we didn't have hashtag here, it might cause like problems, but when we are putting hashtag here, so it's not gonna be a letter here. So, and then it will check all the four corners and it cannot find another E. So what we'll do here, it's gonna put the letter E back here. So it's gonna remove the hashtag from here, and it's gonna put the letter E back, and and then it is going so it's going to be here. So this is going to be removed, and now it will check this corner. It will check 1 and 2, which is C, and it's not equal to E, and then it will check 2 and 3 at this point, and this is equal to E. So it's going to put hashtag here, right? And then it is going to check all the four corners of this. At this corner, it's out of the range, so it's not going to return anything. At this corner we don't have letters, so it's not going to make any changes. And at this corner we have another E, and it's going to put hashtag here. What will happen then when it will call the recursive function again for the next finding the next letter, but when it comes back here, it's gonna check the length of the word is going to be equal to 0, right? So we are not going to have any letter to check. So it's gonna be 0 and it's gonna return true. The time complexity for this case, n is the indication of the number of cells that we have, and L is the length of the word. L is the length of the word that we are looking for, and this is the number of cells that we get from here. And the reason that we have 3 here is the number of directions that we need to go, but we consider only 3 directions because we go forward, so we don't check the behind. And the space complexity is L, and it's mostly because of this stack and the recursive function that we have and backtracking. Thank you.